Okay, let's go over practice exam 2, number 3. All right, let's look at part A first. All right, so we know that, remember that we have this limits, useful limits. So we have a limit of sine of theta over theta as theta approaches 0. And this is going to go to 1. All right, so we try to use this back there. All right, first thing we should do is we're going to try to rewrite tangent as sine of 4 theta over cosine of 4 theta. Right, so we'll have this. Right, we still have to take the limit, right, as theta approaches 0. Then on top you have sine of 3 theta over theta plus, right, you have a sine of 4 theta over cosine of 4 theta. All right, then what we want to do next is we want to kind of force ourselves to create sine of theta over theta expression. Right, so you can see that the sine of theta is on top. So if you divide everyone by, so divide the numerator by theta, and we do the same to the denominator. That way we can create a couple of sine over theta expressions. So let's do that. Right, so you have a limit, still theta goes to 0, right, and on top, right, you have sine of 3 theta, so sine of 3 theta divided by theta, right, and on the bottom, theta divided by theta is 1, which is nice, right. Then I'm gonna try to split sine of 4 theta and a cosine of 4 theta this way. So I'm gonna split into 2 fractions. Right, I'm gonna put the sine of 4 theta here. Right, then I put the cosine of 4 theta here. Right, so since we're dividing by theta, so we're gonna have to put the theta on the bottom. So I'll put theta on the bottom here, and then I'll put a 1 here. Right, so you can see that this is exactly the same thing. I just simplified it. All right, then what we want to do is make sure that when you try to use this limit right here, we have to make sure that the stuff expression inside the sine and the denominator must match. So if you have theta, you have a theta. If you have 2 theta, you have to have 2 theta. Here, you have 3 theta here. So what we need is 3 theta. So what you do is, I'm going to put 3 on the bottom. So I multiply the denominator by 3. Then you're going to have to multiply the numerator by 3. But I'll just put 3 in front so that it looks better. Right, the same thing. If you have sine of 4 theta, so we would like to have 4 theta on the bottom. So I'm going to put 4 on the bottom and I put 4 on top. That way we don't change anything. All right, then we can take the limit. So as theta approaches 0, you can see that this quantity, sine of 3 theta over 3 theta, is going to approach 1. Right, so I'm using that. Right, for the same reason, this guy is going to approach 1. Right, then here, cosine of 0 is 1, so cosine of 4 theta is going to approach cosine of 0, which is 1. Right, so therefore what you get is you have 3 times 1, so 3 on top, All right, then you have 1 plus 4 times 1 times 1 over 1. So it's basically 1 plus 4. So 3/5 is the limit of part A. All right, and part B, very similar. So we're trying to use the same fact that the sine of theta is going to go to 0. So first thing is that we're going to factor out the denominator. So we still have the limit as x approaches 2, right? So you have a sine of quantity x minus 2 on top. Then we can factor out the denominator. So this is a difference of squares. So you can split into x minus 2 times quantity x plus 2, right? So we can split this limit into the expression into these two fractions, right? So we would like to pair with the sine of whatever the inside expression inside the sine over, right, exactly the same thing. So x minus 2, right, times you're going to have 1 over x plus 2, right? I just split into two fractions, but it's still the same thing. All right, so you have sine of x minus 2 over x minus 2. Since x is approaching 2, x minus 2 approaches 0. Also, x minus 2 approaches 0, which is the same situation as this limit we know. All right, so therefore, this limit is going to approach 1, right, from here, right? And since the x approaches 2, so this guy goes to 2. So what's left is 1 times 1 over 2 plus 2. So it's 1 times 1/4, which is 1/4. Right? That's how we get those two limits. Right? That's it. I hope that this was clear.